So in this section, we are going to be asked to compare slopes. So the first graph here on the left, I'm going to talk about that. I have a rate of change that is 1. The slope is 1. The other rate of change is -4. -1/4, sorry. So here, my slope that is 1 is going to be a greater rate of change, therefore it is going to be steeper. Now we want the absolute rate of change. Absolute, you've learned in 7th and 6th grade, absolute value is the positive number. So if we look at -1/4, the absolute rate of change of -1/4 would be a positive 1/4. 1 is still bigger than 1/4, therefore the equation or the line with a slope of 1 is steeper. Now look at the graph on the right. I have a rate of change of 1/3, and then I have a rate of change of 2. If you look at the two graphs, the rate of change of 2, the bigger number, the bigger absolute number, both are positive, so that's okay. The bigger absolute rate of change is steeper. Therefore, the rate of change of 2, that line is steeper because the slope is bigger. So here at 8 a.m., the temperature of City A was 62 degrees. Since 8 a.m. was our first measurement, that's when we started measuring, was at 8 a.m. City A, since that was our first measurement, that means the y-intercept of City A is 62. So between 8 a.m. and noon, that's when we measured the temperature of City A. The temperature increased by 3 degrees, so per hour. Remember, per helps us with determine our slope. So our temperature at any time between 8 and noon is determined by this equation, where T is temperature and H is hour. The table will show City B, and then City C is represented by the equation T equals 54 plus 2H. It wants to know what city has a greater rate of change and what do the rate of change represent. So, rate of change for City C is 2. Rate of change for City A is 3. So right now City A has a larger rate of change, but we have to figure out the rate of change for City B. And if you look, the temperature increases by 2 degrees each hour. Therefore, City A has a greater rate of change. And that means that the temperature is increasing more per hour than any other city. City A has a greater rate of change, and the temp is increasing more per hour in City A. Let's do this again. So at 4 p.m., so 4 p.m. is our first measurement. City A, it was 70 degrees. So that means my y-intercept is 70, because at 4 p.m. the temperature was 70 degrees. Between 4 p.m. and 10 p.m., the temperature decreased by 2 degrees per hour, so -2. So if I were going to do an equation for City A, there would be my equation. What is the rate of change if the temperature is decreasing? Well, the rate of change is -2. My rate is -2. My slope, rate mean the same thing. What does the rate of change represent? Means the temp decreases by 2 degrees every hour. That's what the rate of change represents. Okay, the temperature of the city is represented by this equation. That should be T equals So it should be T equals 72 minus 2H, where T is the temperature and H is the number of hours since 4 p.m. What is the rate of change of the city? The rate of change of the city is -2. And just like before, it means that it decreases by 2 degrees every single hour. That's what the rate of change represents. Whoops. So rate means slope, and slope means rate. And that represents the steepness of a line or how much something is increasing or decreasing. Now, at 8 a.m., so 8 a.m. is our very first measurement. City A, 62 degrees is our initial value because that was our first measurement. Between 8 and noon, again, per hour, M equals 3. So my equation is 62. It increased by 3 per hour. The table for city B and city C is this equation right there, which has a greater initial value. So of my equation, my initial value is 54, right there. City A, my initial value, my first measurement, is 62. And then city B, we're going to say the initial value, we're going to change this to 6 a.m. because that's what the table says. So we're changing that to 6 a.m. So table or city B's initial value is 58. What city has a greater initial value? So city A has a greater initial value. And it represents, it means city A was warmer, or the temperature was higher at 6 a.m. in city A than any other city. That's what the initial value means, because it was our first temperature. It was our first measurement taken. It was 62 in city A, 58 city B, 54 in city C. So therefore, it was warmer in city A for our first measurement. So at 6 a.m. when we took the first measurement, city A was the warmest. At 4 p.m., the temperature of city A was 70 degrees. So our first measurement was 70 degrees. It decreased 2 degrees per hour. So again, here is our equation, which we have already done. But now we want to know what the initial value of the city is. The initial value is 70, and it means that at 4 p.m., the temp in city A was 70 degrees. So now we have this equation. Again, that equation should be equals T equals 72 minus 2H, where B is 72, M is -2. So what is the initial value? 72, and it represents, it means that the temp at 4 p.m. was 72 degrees. So given a line with a slope of 5 over 2, so let's make a line, 1, 2, 3, 4, 5, 1, 2. There's my slope, or my line with a slope of 5 over 2. How does the graph of a line differ if the slope is changed to 1/2? So let's change the slope of that graph to 1/2. So my slope has gone down, so the steepness has decreased. Because the slope went down, it went from 1/2 or 5/2 down to 1/2, the steepness decreases. Given a line with a slope of 6, there's a line with a slope of 6. How does it differ if the slope is changed to 8? So here, the line has become or gotten steeper. The steepness has increased. So since I went from 6 up to 8, that means the steepness of the line has increased. Again, what is another word for rate of change? Another word for rate of change is slope, and it is represented by the letter M. What is another word for initial value? Another word for initial value is y-intercept. And the letter that represents y-intercept is B.